All right, so we're going to pick up where we left off yesterday. So yesterday we finished talking about how to complete the square. Just a quick review of that. Rules for completing the square. You have to make sure your lead coefficient, is 1. You have to also make sure that your quadratic is in the form ax squared plus bx plus c. Again, some of those numbers might be negative, and that's fine, but a has to be 1. Then you move c to the right side to get it to just 2 terms on the left. We make the left side a perfect square by adding b over 2 squared to both sides. You then factor the left side to a perfect square, which you'll learn the shortcut is it's always x plus or minus b over 2 squared. And then you take square root and solve for x. So we did one example yesterday. We're going to start with a secondary example today. 3n squared plus 7n plus 7. All right. Squared plus 7 plus 7 0. All right. So yesterday, the example we had, I made sure had nice numbers. I also want you to see that completing the square works when the numbers aren't quite as nice. So, what is step 1 of completing the square? Make sure a equals what? 1. Does a equal 1 in this case? No, so what do I have to do to make a equal 1? Divide by a. So in this case, we're going to divide everything by 3. So I get n squared plus 7/3 n plus 7/3 equals 0. Now, I know that the fact that this went into fraction land, a lot of you are in the fractions, okay? That this is one of the reasons that I don't use completing the square a ton, but there is times where completing the square is the only option. We'll talk more about that when we get into conics later this year. Okay, so step 1's done. A equals 1 now. So after a equals 1, what's our next step?
Move c to the right side.
Move c to the right. So c in this case is 7/3, so we're going to subtract 7/3 from both sides. If I do that, I get n squared plus 7/3 n equals, oops, I need to leave a space there, equals negative 7/3. All right, we've now got it down to a binomial on one side, but I want it to be a perfect square trinomial on that side. So I now need to find my new c. How do I find my new c? B divided by 2 and squared. So my b value is 7/3. I divide that by 2. Dividing a fraction by 2 is the same thing as multiplying by the reciprocal. So dividing by 2 and multiplying by 1/2 are the same thing. Copy dot flip, if you remember that from pre-algebra. If you do that, you get 7/6. That is your b divided by 2. I now have to square that. Well, how do I square a fraction? You just square the top and square the bottom. So what's 7 squared? What's 6 squared? And I add that to both sides. Okay? Questions so far? So now I got to simplify. So I've got the left side, I can't really simplify right now. We're going to leave it as is. But the right side, how do I add fractions? I have to have a common denominator. Common denominator. What's my common denominator going to be in this case? 36. So I got to multiply negative 7/3 by 12 on top and bottom, which makes that negative 84 over 36 plus 49 over 36. So that makes my right side negative 35 over 36. You with me? The left side stays the same, yes. Now, I got to factor the left side now. So, where I told you that the shortcut was that it's going to factor to whatever the variable is, plus or minus b divided by 2. Well, I don't know about you. I don't want to have to try and do a C method on a fraction like that. And try and find two numbers that multiply to 49 over 36 and add to 7/3. That just does not sound like a good time at all to me. So, the formula, again, like I told you, is we're looking for, well, what was my b over 2 value? So what did I get when I took b and divided it by 2? Well, my b was 7/3. Multiplying by 1/2 is the same as dividing by 2. So that means 7/6 is my b divided by 2, correct? Well, if I take 7/6 times 7/6, I get 49 over 36. And 7/6 plus 7/6 is 14 over 6, which simplifies to 7/3. So that is going to work every single time with completing the square. It's always going to factor to whatever your b divided by 2 is to start. And it takes the sign of b over 2. So if b over 2 is negative inside there, that makes this minus. If b over 2 is positive, like it was in this case, that makes it plus. This shortcut helps you to not have to try and work through all that factoring. Does that make sense there? Okay. Now, so I've got it in perfect square form. Now I got to do what? What's my next step? Take the square root. Take square root of both sides. Well, left side, that's pretty easy. It's just n plus 7 over 6. What's the problem on the right side? Negative, right? So, as Jim just said, there's an I. So, what I like to do here is this. First thing I'm going to do is split it. Because I know 36 is a perfect square, isn't it? Yeah. Okay? So, the bottom here, so I'm going to have plus and minus 6 on the bottom. And then how do I get rid of the negative? I bring an I in. And then we got to see, well, does 35 cake? What goes into 35? 5 times 7, 7 times 1. So does that cake at all? No. So it's just I squared 35. So what do I have right now? I have n plus 7 over 6 equals plus or minus I square roots of 35 over 6. And then what's my last step? Get n by itself. So I subtract 7/6 over. N equals negative 7 plus and minus I square roots of 35. And the whole thing is over 6. So, what does that tell us about both my answers here? They're both complex. So, is there any real solutions for us to graph? No. So, what's that tell us about the graph of this equation? Does it ever cross the x-axis? No, it does not.
It's a lot of work for one problem.
It is a lot of work for one problem. Now, some of you will argue you can do this same problem, do quadratic formula, and it doesn't. Okay? So just to show you, because I told you we talk about the different methods. So if we want to do that same problem, were people not done? I apologize. Everybody good? All right. So if we look at that same problem, so I had what? 3n squared plus 7n plus 7, right? If I want to do quadratic formula in this problem, quadratic formula, it would be x equals negative b plus and minus square root of b squared minus 4ac all over 2a. But the problem we have here, or it's not really a problem, the thing you have to be careful on with quadratic formula is you have to correctly identify what is A, what is B, and what is C. So in this case, I always just write below it standard form, ax squared plus bx plus c, which in this case it's not x, it's n, but you get the same concept. So what's my A value? 3. What's B? 7. And C? 7. Okay? Once you have that, you just plug into the formula now. So opposite of B, negative 7, plus and minus the square root of 7 squared minus 4 times 3 times 7, and that whole thing is over 2 times 3. Well, if I solve this, negative 7 plus and minus square root of 49 minus 85 over 6. Or negative 7 plus and minus the square root of negative, is my math not right there? 12 times 7 is 84.
Rolling Carl.
We'll fix it. Negative 7 plus and minus 49 minus 84 over 6. My fault. Negative 7 plus and minus the square root of negative 35 over 6. And again, can't leave a negative under a radical, so I got to pull out I. So x equals negative 7 plus and minus I square root of 35 all over 6. So, like I said, if your lead coefficient is not 1, is completing the square really a good option? Not really. But there will be times you have no choice but to use completing the square.
And when will be those times?
When we do conics later. For me, I don't really care which way you go about it. Like so here's my policy. If in the homework it specifically says to do it by completing the square, I want you to practice completing the square. If it says to do it by quadratic formula, do it by quadratic formula. If it doesn't say, if it just says solve the quadratic, use whatever method you want. You can factor, you can complete the square, or a quadratic formula. You have to know how to do all three. Now, personally, if I have a choice, I'm going to factor 10 times out of 10. If I can't figure out how to factor it right away, then I'm going to do quadratic formula. And then, for me, completing the square is last resort. But, again, it is a valuable tool. We will use it. All right? Any questions on the difference between completing the square and quadratic formula? Okay. When you learn quadratic formula, it is going to be a formula I expect you to know. You have to know the formula. Okay? So to help with that, some of you are going to find this really cheesy, but there is a song to help you remember it. Okay? All right. It's kind of cheesy, but you'll be fine.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
Okay, you can kind of hum it to Pop Goes the Weasel, and it helps you to remember the formula. When I was in high school, this is how I had to teach myself how to do it. So, and no, we're not going to watch the One Direction cover of that. So, I mean, if
Hey guys, does this day sound familiar? You go to a confusing lecture, you ask for help.
The first thing about the quadratic,
I'll let you watch it.
what we're actually doing. The first part is we have a quadratic function, a squared plus bx plus c equals 0. We have a quadratic function set equal to 0. We're using the quadratic function of negative b plus or minus the square root of b squared minus 4ac all over 2a to find where the function crosses the x-axis or the function is equal to 0. Okay? So there's a tune that pretty much knows by One Direction that we will use to memorize this formula.
That's him.
Get out of my head, fall into my arms and you say, I don't know.
Hey.
I knew that one thing, you got that one thing. Good. So if we use that same chorus, we can sing the quadratic formula right here behind me. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you know the quadratic formula.
There you go.
Now you know the quadratic.
All right. So you have whatever way you need to help yourself to learn that formula. Okay. So we're gonna do another example here with quadratic formula. So. All right, so here's our scenario. Okay, so for those of you that are baseball fans, you know who Mark McGwire is, hopefully. Played for the St. Louis Cardinals, okay? He hit a lot of home runs, but he occasionally also popped out. So suppose the ball was 3.5 feet above the ground when he hit it straight up with an initial velocity of 80 feet per second. So the equation we're going to use is this: 80t minus 16t squared plus 3.5. Okay, this function gives the ball's height above the ground in feet as a function of time in seconds. So t is time in seconds, d of t, or y in this case, is the height of the ball. How long did the catcher have to get into position to catch the ball after it was hit? So that's what we're trying to figure out. So, given this equation, first off, what do we want? So when it's saying, how long does the catcher have to get into position to catch the ball? Well, what is that insinuating? If he's getting underneath it and is able to catch it, that means how long before the ball hits where? The ground, right? The ground. Because if the ball then hits the ground, he's able to be safe, right? Here he has the opportunity to be safe. Well, what is the ground in terms of height? 0. So what we're trying to find here is when y equals 0. But what's the other problem we have in this case? Is this equation in the right form?
No.
But can I rewrite it into the right form? I just switched these two. So I get 0 equals negative 16t squared plus 80t plus 3.5. Now, again, we have the option to try and factor this. But do you want to factor when you have a decimal? No? Do we want to try and do completing the square here with negative 16?
No way.
So what's our best option here? Quadratic formula. So, if we're doing quadratic, that's A, that's B, that's C. The formula again is opposite of B, plus and minus, square root of B squared minus 4AC, all over 2 times A. So, what goes in for B? 80 plus or minus 80 squared minus 4 times negative 16 times 3.5. That's all divided by 2 times negative 16. Everybody with me so far as where I got those numbers? Okay. For sake of time, I'm just going to keep working. So you got negative 80 plus or minus the square root of 6,624. Which, lucky for us, does not cake.
24. You're just guessing, aren't you?
No, it doesn't.
How do you know?
Because I have the answer right.
Uh,
All right. So, if I solve this, I have 2 options. Okay? My 2 options are negative 80 plus the square root of 6,624 over negative 32, or negative 80 minus the square root of 6,624 over negative 32. And we can find these as decimal answers now. If I solve these, I get that the 2 possible times are approximately negative 0.04 and approximately 5.04. So we have to look at this logically. What does that first answer, negative 0.04, insinuate? He has negative seconds to catch the ball. So that's saying his first opportunity to hit the ball is 0.04 seconds before Mark McGuire even hits it. So does that make sense? No. So that means the only possible answer here is 5.04 seconds. So that's telling the catcher he has 5 seconds to position himself and try and catch the ball before it hits the ground. Well, so what is this little symbol up? What does that little double tilde mean? Approximately. I rounded. It's not an exact answer. Because if you plug that square root of 6,624 into your calculator, you get kind of a nasty decimal. So, all right. Any questions on that? Okay. We're not quite done with this section. We have a little bit left, but we're getting really, really close. So tomorrow, we will finish this up. All we really have left to talk about is the discriminant and the types of roots from the discriminant. And then after that, we'll have the rest of class. Well, it's an early out tomorrow, so that'll probably take most of the time. You will get your homework from 4 to tomorrow.
Eventually we'll have to that one kind.